Morning. Today we are going to discuss the subject on additive manufacturing process. So, what is meant by additive manufacturing and where we can make to apply this one? So, the additive manufacturing is the name is called rapid prototyping, where is used other name is also called 3D printing, other we call. So, why we required is used to variety of industries in order to describe for rapid creating of a system or part representation before final release to the product. So in order to create something quickly, that output of prototype or basic model which can make to final product will be delivered, we require this RP or additive manufacturing. So in this we have system history development, why we required and what is the difference between additive manufacturing and CNC, and the classification of additive manufacturing process and the raw material based chain process benefits and applications. So in order to make this, we need to represent some softwares, that is our rapid prototyping data formats that we will see one by one. So what is the before making to rapid prototyping, we need to define the manufacturing process. So normally manufacturing which can make to convert the raw materials into the finished products, or we can make to give the by various process of using tools, machinery and computer. So during manufacturing, we are going to be add the material or subtract from the materials. So in order to give the whatever the desired property or shape of the workpiece has given by the dimensions of the drawing, we require by subtracting and adding the material. So what are the classification we are going to be before making RP? We need some classification of normal manufacturing process. So broadly classified six categories. Primary manufacturing, that is called primary shaping process. So casting, powder metallurgy, plastic technology, and deforming process, that is like compression test tension shear to cause the deformation of the plastic materials in order to produce the required shapes without changing its mass and material composition. And then in the same way, we can make to give the like no material is removed or added, like forging, like hooks, like we are going to be forging operation, extrusion, rolling, sheet metal operation. And third one is machining process, where normally we are going to give the material is going to be removed, that are called uh, machining process. To generate the workpiece surface, definitely we need to remove the workpiece material in order to give the relative motion between the workpiece and tool. The tools are going to be remove the workpiece material, that is like turning, milling, drilling, grinding, and unconventional machining process like electric discharge machining, chemical machining, water jet machining. These are modern manufacturing methods where we can make to without tool contact, we can able to remove the materials with help of mechanical energy, chemical energy, or thermal energy. Under other classification is joining process, that is called two or more material parts are going to be joined with a sub-assemble for final product. That is called pressure welding, diffusion, brazing, soldering, and resistance welding, explosive weldings. All this one we are going to be joining process. Next is the surface finish process. So in order to make better surface finish after final machining process, we need some surface treatment. So for getting output testing property, we can make to give the that is property is going to be material removed or added in order to surface of the job. Some small irregularities are going to be occur. There we can make to give the surface finishing process, like plastic coating, metallic coating. Moreover, we are making lapping operations or electroplating process. Next important manufacturing material properties modification process, like heat treatment. So some heat treatment process is required in order to give the change the properties of the material or phase. We require some heat treatment and surface treatment by giving the temperature process, and annealing process, which is going to be one of the most important heat treatment process. So by considering all this manufacturing, next important is additive manufacturing. So we are making already we discussed part representation, that is a rapidly creating system. That part representation, that is we have to process in this one the 3D design. So whatever we are making to drawing the process three-dimensional view, we can make to build a component in layers by depositing layer by layer material. So this rapid prototyping or additive manufacturing technology is going to be improvement in quality output with respect of directly with the prototype. So we are making some ASTM international standards we have process. This first important is to generate three-dimensional computer aided design system. That means can be fabricated directly without needed process of planning. So the 3D objects directly from CAD data, which can make to detailed analysis like part geometry in order to determine things like different features can be fabricated. So the main additive manufacturing is the CAD data. That is each layer must thickness, how much is going to be processed in this one. So it is also in the form of a layer by layer approach. So additive manufacturing is also used a layer by layer approach in this one. So it is also called 3D printing, rapid prototyping, or layer by layer manufacturing process. On the other name is also it called. So additive manufacturing is going to be using the 3D system of three-dimensional CAD model in order to real world product, where this we can make interface software and hardware with respect of actuators, sensors in order to give the shape to the product. So before making there is a development. So with respect of variety technologies, we can make to storage cost, we can customize the additive manufacturing missions. Later we can make to process in this one. Why we required comparing with other manufacturing process also is there. Why almost any shape geometric features can be produced. So we are making one of the major point is nowadays customers requirement is very essential, and also the product should be released the market within the less time. So one of the important why we require additive manufacturing is the less time can make to create more features of the product, and time and cost already we discussed, and flaws errors can be detected at an early stage. So this is major advantage why the need is going to be the errors can make to edify with respect of in early stage. So assembly can be made directly even, and material waste is almost going to be reduced. And another point is the no tooling is necessary, whereas in normal manufacturing process the tool material should be harder than the workpiece material. This is somewhat task for making to select the material of workpiece, but that when conventional machining process like turning, milling like that, we need to define that the tool material should be harder than the workpiece material. Whereas in a additive manufacturing, that is the no tooling is necessary. And what is the difference between CNC, computer numerical control, and additive manufacturing process is nothing but there we can define the 6 pointers, 6 points: material wise, speed, complexity, accuracy, and the total geometry of the product, and finally the programming. So what were the materials? So additive manufacturing technology developed with the polymeric materials, waxes, paper, laminates, all this we can make do process. And moreover now introduce composites, metals and ceramics. Whereas in CNC machine can be used for soft materials like medium density, fiberboard, machinable forms, waxes, and even some distinction between the machining polymers. Speed, very important point of the comparison between additive manufacturing and CNC. High-speed CNC machines can generally remove material obviously much faster than the additive manufacturing with the same similar volume of material. However, the CNC machines require considerable setup and process planning before making. When the part is complex in geometry, then we have to consider the speed. To make the part in AM machine, it may only to take few hours, and in fact, multiple parts are also attached in this one. That is the speed. Complexity, as mentioned earlier, the geometric complexity is greater advantages AM has over CNC. In CNC, when we want to make a single piece, there are some geometric features cannot be fabricated machine tools, carried, spindle, certain accessibility is required. Whereas in AM process, it is not constrained in the same way where they can make to features can make to build with a specific process planning. So accuracy generally with a few test of macrons, variable resolution with the respect of this one. And geometry is going to be always we can make to discuss three-dimensional, with two-dimensional can make to process. So cannot easily done in CNC, whereas in additive manufacturing we can make to mostly normal surfaces in the and programming where we require CNC machine can be involved. That is where the tool selection, how it is going to be tool selection, and when we can make the speed settings, all this one. Whereas in additive manufacturing missions that may be selected with only range and complexity with the surrounding of minimum in comparing with the CNC programming missions. So what are the classifications of CNC, sorry, additive manufacturing process? There is three basically classified on liquid, powder based, solid based. So liquid based, moreover we are all aware of that stereolithography is one of the major important point of the additive manufacturing system. And forward based is SLS, three dimensional, that is selective laser sintering. Fused deposition molding or fused deposition system is a very important rapid prototyping or additive manufacturing process making to give the good products to be processed. And selective making sintering, selective high speed sintering, solid based fused deposition molding, all this is the additive manufacturing classification. So we are making with respect to of all this, we have to give the classification based on three types. Next important is the additive manufacturing process chain. So it is majorly 8 points, that is computer aided design. So step one is we are making all additive manufacturing parts must start from software model that describes external geometry. So first important point is the CAP. So we must start with the reference of software to describe whatever you are designing of the external geometry. This can involve professional CAD solid modeling package software. So, but the output must be in 3D solid or surface representation. So, it can make to use the first and foremost is the step one is CAD. Next one is the conversion to STL. So AM mission is attempt to STL format. This is going to be de facto standard. Every CAD system output can make in a file format. This file describe what externally closed surface of your original CAD model and basis for calculation of slices. That means we need to give the slices wise transformation with the process. Next is transfer to additive manufacturing mission and STL file manipulation. So this STL file describe the part must be transferred your additive manufacturing mission. There some general manipulation is there, correct size, position, orientation, all this we going to be processed. So here very important point, general manipulation, that is the whether it is a correct size, position or orientation of the building where we can make to process. So this is going to be the machining process. Next one is the mission setup. So this AM process is going to be properly set up. So prior to build a surface, settings related parameters like energy, layer, timing, material constraint, all this mission setup is required. Next, fifth point is build. That is building the part, an automated process that large with supervisor. That means this time there will be no rest we can make to take. The material should make to build layer by layer. So next sixth point is removal. So once the AM mission has completed the build, the parts must be removed. This may require with respect of interaction with the mission setup where safety interlocks for operating system. For example, when we are making some temperature concern, what are the operating temperature are sufficiently low or there is no actually moving parts, like that we have to see before making to remove the part from the build we can make to process. Next important is post processing. Once the removed from the mission, parts may require an amount of additional cleaning. So before making to ready use, any weak at the stage, they may have to support structures. Sometimes when in additive manufacturing process, some overhanging structures like that, definitely we need some support structures. That much may remove. When we are removing the required time and careful with the manual manipulation. So that why the additional treatment is required. Next one is the applications. What was the parts now ready to use? We can require additional treatment before acceptable. We can make to require. For example, we require some priming and painting to give acceptable surface texture and finish. We treatment by the process. This is some demanding require. We can make to go the optional application wise. So we can make to use it like this structures of all this classification. So these are the total 8 components where we can make to finally STL, CAD model, removing, post processing, all this one. What are the advantages? So complexity free and elimination of production steps. So definitely we are eliminating steps of this and making to create by the short period of time and complexity. What are the disadvantages is slow build rates, and production cost is somewhat high, and limited component size with considerable effort with application design. So the application wise consider automotive, biomedical, aerospace, goods, and many others we can make to uses. So like current and potential industries for additive manufacturing, we are using aerospace, dental, jewelry, automotive process, which is going to be automated fabrications where we can make to monitor all this system. So additive manufacturing is going to be one of the major current and potential industries. So we need to CAD model represent in STL format. So that is called stereolithography, which is the first commercial additive manufacturing in 1980s. We can make to STL. That term should be stand for stereolithography tessellation language, also known as standard tessellation or tessellation language (STL) format. So we are making to generate CAD with a CAD system of 3D, the boundary representation, mesh triangles, all this we can make to represent. So these STL files can describe total surface geometry of your three-dimensional object by making without any representation of color, texture with respect of common attributes of CAD model. So what are the types of standard decimal language files? That is American Standard Code for Information Interchangeable. That is called the large file size. Binary format. So small file size we can make to use as a binary format, and large file size we can make to use as a process in this one. So we are making this type of a STL format is unordered with respect of triangles. So it cut an another edge. What is the direction of triangles? Facet. Facet is nothing but by making to and surrounded by three faces. An edge is going to be two faces where we can make to discuss the area. We have to define the STL with respect of what are the outside and overlook or envelope the system. By making this, the file make to get the performing of the STL. So for making the function of STL file, we are making some boundary representation on the constructive solid geometry. So before making the CAD models with respect of standard Tesla languages, we have to some representation in the format that is called slicing part, which is comparing with the easy to other methods such as boundary representation and constructive solid geometry, which can give the total entities of our product. So after making this STL, we need some data generation. So for making export in STL format, the solid system CAD systems can allow the borderline tolerances, which is going to be useful. So for that, as a process, we have to calibrate what each slice of profile and specify the elements. Any problems with STL files, with that manipulation and additionally additional software we can make to assist for total additive manufacturing. So to here we can stop. Next class we will discuss. Thank you.